Find the range and the interquartile range for each set of data. Now the first set here we can see is already in numerical order. There's 1, 2, 3, 4, 5, 6, 7 pieces of data. 7 plus 1 divided by 2 gives us 4. So the fourth piece of data is the median. 1, 2, 3, 4. So the median is this 28 here. That gives us a sublist of length 3 here and a second sublist here. The sublists are of length 3. 3 plus 1 divided by 2 is 2. So the second piece of data in each list is the quartile. This one's the lower quartile, this one's the upper quartile. The range is just the biggest take away the smallest, so that's 33 take away 20 gives us 13. Let's just make a little bit of space by getting rid of these calculations over here. That's actually difficult to do, so let's just get the eraser, see if we can get rid of them. There we go. And the interquartile range is going to be the upper quartile take away the lower quartile. So that gives us 8. Now for the next data set, it's not in order, so we need to put it in order first. It looks to me like the smallest piece of data is a 5. We then have a 6. I can see 2 7s. Can't see any more. There's an 8. There's a 9. There's a 10. An 11. A 12. 2 14s. And finally a 15. Let's just count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And we started with 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we've probably got it right. So 12 pieces of data. 12 plus 1 divided by 2. So that's going to be 13 over 2, which is 6.5. That means that the median is between the 6th and 7th pieces of data. 1, 2, 3, 4, 5, 6. So the median is 9.5. And note we get a sublist below the median with 6 values in it, 6 values above the median. So 6 plus 1 divided by 2 gives us 3.5. That means between the 3rd and 4th pieces of data. 1, 2, 3, lower quartiles in this gap. 1, 2, 3, the upper quartile, sorry, is in this gap. So my lower quartile, or Q1 as we often call it, is 7, and my upper quartile, or Q3 as we often call that, because the median is sometimes called Q2, this one is 13. So my range is going to be biggest take away smallest, gives me 10, and my interquartile range is the upper quartile take away the lower quartile, and that gives me 6. Now let's look at part C. It's not in order, so the smallest piece I can see is a 7. Then I've got 8 and 8. Then I've got a 9 here. I've got a 10, a 12. I've got the 15 just here. 25, 26, 26. I missed the 24 there, so it's very easy to do. So 24, then the two 26s, and then two 28s. Let's count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. And originally we had 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So that's good. So 13 add 1 divided by 2 is 7. The seventh piece of data, 1, 2, 3, 4, 5, 6, 7. That is our median. It gives us a sublist here of length 6 and a sublist here of length 6. We've already dealt with 6, so we're going between the third and fourth piece of data. 1, 2, 3 in here. 1, 2, 3 in here. So our lower quartile, let's call it Q1 this time, would be 8.5, and our upper quartile, Q3, is 26. So the range is going to be 28 take away 7, which gives me 21. And the interquartile range is going to be 26 take away 8.5. And that gives me 17.5. So the interquartile range, what does it tell you? So the interquartile range of 17.5 tells us that the middle 50% of the data spans 17.5 units of whatever we're measuring. Now we could go further, I'm not necessarily going to write it out, but the range is 21 and the interquartile range 17.5. So there's not a big difference between the two, and that would suggest to us that there aren't any outliers in this data.